Today we are going to be talking about Unit 2D. We are going to simplify radical expressions containing rational numbers and variables. Mine is going to start on page 18. Remember, your numbers may be a little different. So at the top of my paper, I'm going to number it, the page number, the title, and then we have a couple of definitions we need to discuss today. The three of them being what perfect numbers are. Perfect squares are the product of rational numbers being multiplied by themselves. For example, 2 times 2 is 4. 3 times 3 is 9. The 4 and the 9 would be considered perfect squares. Perfect cubes are the product of rational numbers that are multiplied by themselves 3 times. So an example of this might be 3 times 3 times 3, which is 27, because 3 times 3 is 9, and 9 times 3 is 27. So 27 is considered a perfect cube. Perfect fourths are the product of rational numbers multiplied by itself 4 times. Or we could say that it's a perfect square multiplied by itself. So an example of this could be 2 times 2 times 2 times 2, which ends up being really 4 times 4, which is 16. Or we could say 4 times 4, which is 16. So we take a perfect square and multiply by itself. We are going to be using perfect squares, cubes, and fourths when we simplify our radicals. Now let's talk about what a radical actually is. And a radical can be many forms. The three that we're going to talk about are going to be a square root, a cube root, and a fourth root. What makes them similar is that they all use the radical symbol, which is just this basic symbol here. If there is no index, which we'll talk about the different parts in just a minute, then we assume that it is a square root and we're looking for the perfect squares. You should have picked up this piece of paper when you got your computer. So go ahead and tape this or glue this into your notebook. We are going to talk about the parts of a radical. There is something known as an index. This is the little number before the radical sign that tells us what we're looking for. Are we looking for squares or cubes or fourths? If there is no index, we assume that it is a 2, which means we're looking for perfect squares. The radical sign tells me that I'm looking for numbers that are multiplied by themselves. And the radicand is the number inside. That's what I want to be able to simplify. So we're going to take a look at a couple of examples. We're going to start off with a square root. Then we're going to look at what happens when we introduce a coefficient in front of the square root. And then we're going to take a look at a cube root as well as a negative number and when that's acceptable. So what we want to do here is we want to take a look at the numbers themselves. So as you can see, in my first example, I have the square root of 117. I'm looking for two numbers that would multiply to give me 117. So what I'm going to do is I'm going to use my calculator, and I'm going to divide 117 by 2. Now I know it's not divisible by 2 because it's not in even ones place. So instead, I'm going to go up to 3. And because it divides by 3, I can say that 117 is 3 times 39. Now I'm using the tree form. Other people might write this out differently. I'm then going to divide 39 by 3, and I get that it is 13. So what I can see is that 117 is really 3 times 3 times 13. But because I'm looking for a perfect square, I'm looking for two numbers that are identical, and I just so happen to have two 3s. So the 3 is going to come outside, and the 13 that's left is going to stay underneath the radical symbol, and so my simplified version is 3 square root of 13. And that is the same thing as the square root of 117. We're going to use those same skills to come over here to example 2. This time around, I have a coefficient in front, and so that coefficient is going to stay. What I'm worried about is, what is this 320 simplify to? Because it ends in a 0, I know that it is divisible by 5. So I'm going to start 320 divided by 5, and I know that it is 5 times 64. Oh, 64, that number sounds familiar, and I'm going to remember that I can divide it by 8. It's actually a perfect square. Sometimes we'll get lucky and we'll get these perfect square values. So because this is a perfect square, the 8 is going to come out in front of my radical. The 5 is going to stay underneath because it didn't have a perfect square to go with it. The only difference between these first two problems is I had a 4. So that means that the 8 needs to be multiplied by the 4. So really, 4 times the square root of 320 is 32 times the square root of 5. So make sure you multiply anything you bring out times that 4. The last example we're going to take a look at is a cube. That means I'm looking for numbers that multiply by themselves 3 times, and because it's negative, I'm looking for 3 negative numbers. It ends in a 0, so I know it's divisible by 5. So I'm going to take negative 250 and divide it by negative 5. And that gives me 50. I'm going to take 50 and I'm going to divide it by 5. And that leaves me with a 10, which really could be a negative 5 and a negative 10. And negative 10 is divisible by 5 because it is a negative 5 and a positive 2. And the reason why I went negative is because I need the same number. So now I have 3 negative 5s. So the negative 5 comes in front. I have a cube root, so I need to make sure that index is a 3. And then the 2 is left over. And so when we simplify with just numerical values, we're looking for either perfect squares, 2 numbers that are the same, or perfect cubes, or if it was a 4th, then I'd be looking for 4 of the same number. We're now going to take a look at what happens when we introduce variables into these problems. Okay, so when we simplify radicals with variables, we want to remember 3 things. When we simplify them, they're going to have exponents on the problem. So we're looking for exponents that are multiples of 2, multiples of 3, or multiples of 4 in order to be able to simplify the 4th root, cube root, and square root. So I'm going to come down and I'm going to look at the square root of 32 times x to the 4th, y to the 9th. I'm going to simplify 32 to be 16 times 2. That is hard to see, so let me write it in pen. 16 times 2. X to the 4th, I'm going to rewrite as x squared times x squared. And we're going to remember our exponential rules from the last unit that said that we would add those together. So that's where we get the x to the 4th. And then y to the 9th is y to the 3rd times y to the 3rd times y to the 3rd. So now what I'm looking for, and I can break this down a little bit further, 16 is a perfect square, which is really 4 times 4 times 2, and then we have our x squares, x squared, y cubed, and our y cubed. I'm looking for 2 of the same. So I have 2 4s, I have 2 x squares, and I have 2 y cubes. So outside comes a 4, an x squared, and a y cubed. And anything not circled is going to stay under the radical. So I'm going to leave a 2 and a y cubed under the radical. And so I have simplified the square root of 32 x to the 4th, y to the 9th to be 4x squared y cubed times the square root of 2y cubed. Now we're going to take a look at a cube root. Remember, you can pause at any time. So we're going to look at the cube root of 56, r to the 8th, s to the 4th. So remember, I'm looking for numbers that are the same, but I want 3 of them. So I'm going to use my tree method on this one instead of the horizontal method. 56 is 2 times 28. 28 is 2 times 14. And 14 is 2 times 7. So here's my 3 2's. R to the 8th power, I'm going to break down. I want to be multiples of 3. So I could do r cubed, but then I wouldn't have enough. So I'm actually going to break this apart into squares, because what this does is this allows me to get 3 of the squares. And then I have s times s times s times s. And so I have 3 s's. And so I have 2r squared s times the cube root of 7r squared s. Remember, I need that index in my answer to match the index in my original problem. And the last example that we are going to take a look at is going to be a 4th root. So this time around, we're looking for 4 numbers that are the same. We're going to start with 48m to the 8th power n cubed. So I'm going to break 48 up into 48 breaks up into 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. So here's my 4 2's that I need. M to the 8th, I'm going to go ahead and break those up into 2's. M squared times M squared times M squared. You can do singles and group them. You'll end up with the same answer, and then n cubed is n times n times n. So I have 4 m squares. I have 4 2's. I don't have enough n's. So my answer is going to be 2m squared times the 4th root of 3n cubed. There's not enough n's, so they go back under with a root of 3. We will have lots more to practice in class. Come with any questions.